Out some examples, just kind of step it up one notch. But GCF in general, you're looking across the boards at the numbers. So the GCF for the number portion is 3, and the GCF for the variable portion is X. What made you choose X, by the way?
There's no X squared and none X.
Could someone describe in another way why you pick X? Because they both have a maximum. In other words, because that has the smallest exponent on it, yes? The exponent of 1 is smaller than 2. We'll just need that maybe Monday for something else new about factoring that you'll learn. Difference of perfect squares. Obviously, a perfect square is something that you can take the square root of. These always factor into conjugates. So the square root of this is 6x. And the square root of that is 5. So it factors into 6x plus 5 times, I'm going to go left, 6x minus 5 in either order. But difference of two squares factors into conjugates. I'm going to come back to B and C later because they require trinomial stuff. Prime polynomials, a prime number is something that really can't be factored into anything other than 1 times itself. So prime polynomials are the same thing. They really can't be factored unless you pull out a GCF of a 1 and then just leave it as is. So this just can't be factored. It's just done. But notice that. What's that? We're not going to do that here. I don't think. I don't know. This textbook will not do that yet. Anyway. And if you had me for Algebra 2, I don't do that because I've never seen it on a region. So. The key here is you see perfect squares. Don't think that that's conjugates if it's the sum, because that conjugate rule only works for the difference. Okay? Perfect square trinomials. This is going to be different. How many of you guys use the box method for factoring? No? Use it regularly, like that's your preferred method. Nobody. Okay. Well, good. I don't bother teaching my own Algebra 2 kids that either, because what do you do? Guess.
Guess and check. Yeah.
Guess and check, essentially. Yeah. And maybe you would do that with this one, but you might be a little bit, because these numbers are bigger, it might take you a little longer. A special pattern to pick up on. It's the same special pattern we kind of unraveled the other way when we were squaring a binomial. But if you notice that this is a perfect square, what's its square root? 5x. And you notice the last term is a perfect square. What's its square root? 3. And what do you get when you multiply those two together? 15. And you see how the middle term is double that. If you see that, then and because the middle term is a plus, that's just a plus, and it's that binomial squared. We talked about that shortcut moving forward the other day. If your problem starts like this and you're asked to simplify, we did that shortcut kind of going forwards, and this is just kind of stripping it backwards the other way. Mike, what's the problem?
I was asking if we learned this.
Oh, did you? No?
I've never done that before either, yeah.
You guys probably just did 5x plus 3 and 5x plus 3 and just kind of guessed and checked. Right. So no one shed light on it for you, but it's there. And then the second one, and it only happens, obviously, if this is a perfect square. If this is a perfect square, and if when you multiply them and double it, it gives you the middle. So these multiplied gives you 28. Double that, it is 56. Because this one is a subtraction, it's going to be 4x minus 7 squared. You guys would have gotten this. You just would have done it 4x minus 7 next to 4x minus 7, and been like, oh, it's the same thing, and you maybe would have written it that way at the very end. So you've done it, but just maybe didn't realize that. Yep.
So like I said, you're telling me that 5x plus 3, and then like times another 5x plus 3 is going to get 25x squared plus 30 plus 9?
Yeah.
That's crazy.
Didn't I do that last week moving forward? Like if I told you last week to simplify this, I tried to tell you don't have to expand it every time. You can square this
I don't know if I thought it was like
to get the first term. You can square that to get the last term. And then you can multiply them together, 15x, and double it to get your middle term.
We did this last year.
Yeah, we did. I always talk about that. All right. Then your basic trinomials, you guys just guess and check. So this first one's pretty easy because there's only one option to get x squared, x and x. There's a few options to get negative 12, but because you don't have to kind of mix and match with different options of the first one, what are they, Ryan?
3 and 4.
Yeah, signs.
Negative 4 plus 3.
Good. Yeah. So the main thing you want to check when you're picking things that make 12 and you're picking things that make x squared is that your outer positive 3x and your inner negative 4x combine to get that middle term. Your outer and inner need to combine. That's really the check part. Your guesses are guessing what makes the first two terms, guessing what makes the last two terms. B is going to be tougher. And here's why. You can pick 1 and 15 or 3 and 5. And then you're going to have to go through all the combinations of that with 1 and 6 and 2 and 3 or 6 and 1 or 3 and 2. So that's actually not a terrible number of guesses and checks, but let me review with you. I call it splitting the middle term. It's got some similarities with the box method, so maybe this is how you do it. Do you guys pick two numbers that multiply to get 15 times 6? Yes? 15 times 6 is 90. So I'm essentially going to find two numbers that multiply to get 90. If you want to list them, you can. 3 and 30. I mean, you can list them all just and get that out of the way. Or maybe you think you'd come up with it on your own. That combine to get negative 19. So far, I don't have one there, do I? 4 doesn't go into 90. 5 goes in 18 times. 6 goes in 15 times. 9 goes in 10 times. So which one of those combos gives you 19? 9 and 10, right? So when you find the two numbers that do that, they multiply to get that AC product. You know what I mean when I say AC product? You know, like ax squared plus bx plus c. So they multiply to get the AC product, but combine to get you the B number. It's actually going to be a double negative, because the double negative will still get me positive 90 when I multiply, but it's going to combine to give me negative 19. So when you find those two numbers, I use that to uncombine the middle term. So 15x squared will stay, but I'm going to uncombine like terms so that I can now do what? Grouping. I think, Ellie, there's probably still not a GCF.
I've never done this before, though.
Yes, this is like mind-blowing.
So, okay. So group, I'm going to take out 3x. Well, you know what I found? In the second group, I'm going to take out a negative 2. And then obviously grouping worked because 5x minus 3 matches. And I'm done. What I found is that guessing and checking is great if people actually check. What I always find a struggle is that some people just like don't check, don't really get the check, and just for whatever reason. And when there's a gazillion combinations, like if you ever had a 12x squared at the beginning and like a 24 at the end or something like that, that would be a gazillion different combinations. You lose, there's so many guesses to have to check that you lose track of what you've already checked and what you haven't, and to me it just gets frustrating. So this is like a foolproof way, you know, that will always get you the answer right away, and the only thing you have to do is really sift through your factors and find the right two numbers to split the middle term. Your box method was, though, a similar concept. No? Doesn't even ring a bell.
I never.
Yeah, but I used to do like
All I remember is like you do like
15.
multiply add like that man.
Yeah.
What
What do you call it?
BAM? I don't know.
Huh. I don't
It used to
know.
take forever, so I'm surprised they didn't teach us like this.
I
Okay.
used to do 5 times, like, say it's 5 times 3, and then you have to do.
Yeah, but
it had
if-
to be 3.
Yeah.
6, and then the middle had to.
You had to guess and you guessed and checked, but that can get
It's so much easier.
that can get busier. All right, so grouping, I'm not going to do B and C because we just reviewed grouping in the previous problem. A, just the appearance of it. It's almost like in the mid grouping process. It's right in the middle of it. But if you look at these two terms, They both have that x squared plus 2. So I'm going to take the x squared plus 2 out in front, and I still have an x on the first term, and I still have a plus 3 on the second term. I just need to go back up to 2, B, and C, the ones that I skipped. I skipped them because they weren't straightforward as far as being the difference of perfect squares. This is a perfect square. This doesn't really appear to be one, but now that we know that shortcut, this is a perfect square, we can factor this trinomial. This has a perfect square of x. This has a perfect square of 4. That gives you 4x doubled is 8x, so it's that shortcut where I can just put plus and squared. And I really kind of group this 3 by 1. So there's the first term minus, there's the second term, and now it's the difference of perfect squares. So the square root of this is x plus 4, and it's going to be plus a 5a, and then an x plus 4 minus a 5a. And C is the exact same problem, just needs a little rearranging. That minus 36a squared needs to be moved to the end. So it should be x squared plus 20x plus 100 minus the 36a squared. And then I can factor that trinomial into x plus 10 squared minus the 36a squared. And then the conjugates will take it to the end. X plus 10 minus 6a, x plus 10 plus 6a. Okay? All right, 1s, 3s, and 7s.